Hello students, welcome to this session. In this video, we study about one more continuous priority distribution that is called as normal distribution, and this distribution is also called as Gaussian priority distribution. And this particular distribution has wide applications in almost all the engineering fields. As usual, every priority distribution, either it is discrete or continuous, has one priority function. Okay, here a continuous random variable which has the following priority density function given by f of x equals to 1 divided by root 2 pi into sigma e raised to minus 1 upon 2 sigma square into x minus mu whole square, where x lies between minus infinity and plus infinity and mu lies between minus infinity and plus infinity, and sigma is greater than 0, is called normal variate, and its distribution is called normal distribution. Again, as usual, this particular normal distribution has also certain function like this, and this is called its priority density function. Once we look at this particular function carefully, we find that there are two constants. One is called mu, another is sigma, and these two constants mu and sigma are called as parameters of the distribution, and a normal variate x with these parameters is denoted by n x comma mu comma sigma, or it is also denoted as x follows normal with parameters mu and sigma. Now, generally, the geometrical meaning of a function is it represents a curve. Like that, if you plot this curve with the known values of mu and sigma, the curve seems to be like this, and this curve is symmetric about the line x equal to mu. Once we observe the curve, we find that the graph of the curve is bell-shaped and is symmetric about the line x equals to mu. Now, once we come across with the two main concepts of error distribution, that is mean and variance. Suppose x is a normal variate with parameters mu and sigma, then mu is referred as mean, and sigma square is referred as variance, and sigma is referred as standard deviation. And now associated with normal distribution, there will be a small part which is going to be called a standard normal distribution. Before that, once we have to be familiar with that concept, that is a standard normal variate. A normal variate with mean 0 and standard deviation sigma, or variance equal to 1, that is sigma square equals to 1, is called as standard normal variate and is denoted by the letter Z. Suppose x follows normal with parameters mu and sigma, or with mean mu and sigma, as you have stated here, with mu sigma and standard deviation sigma, with mean mu and standard deviation sigma, then the standard normal variate is denoted by Z and is computed with a simple rule that is given by x minus mean and divided by standard deviation, where x is a normal variate, mean is given by mu, and standard deviation is given by sigma. That's why the standard normal variate is defined as normal variate minus its mean divided by standard deviation. And this particular variable also follows normal distribution with mean 0 and standard deviation 1, because as you have stated here, a normal variate with mean 0 and standard deviation equals to 1 is called as standard normal variate. That's why this follows normal distribution with mean 0 and standard deviation 1. You have to keep this particular thing in mind until the completion of this distribution. That is, for a normal variate, the standard normal variate is computed as value of the variable, that is x minus its mean divided by standard deviation. Therefore, this is a rule to convert normal to standard normal. That is, value of the variable, that is x minus its mean divided by standard deviation. And once you take these particulars in the normal priority function, okay, if we take x equals to z, mu equal to 0 and sigma equals to 1, we are going to get one more function like this, and this is called as normal probability function of standard normal or standard normal variate, or this is also called as probability density function of standard normal distribution. And this is going to be obtained, as we said, by taking mu equal to 0, sigma equal to 1, and x equal to z in the normal probability function, and is called as probability density function of standard normal distribution. Again, this seems to be one function, and again, once you plot this function, the graph of the function seems to be like this. Okay, and in this case, this curve is symmetric about the line z equal to 0, left side minus values, right side plus values, as it is symmetric. Okay, and we know that total probability is 1. That's why we have written area from minus infinity to plus infinity as 1. And since it is symmetric about the line z equal to 0, therefore the left half covers 0.5 and the right half covers 0.5. And the shaded area in the figure represents the probability that the standard normal variate lies between 0 and z1. It can be read from the standard normal table for a known positive value of z1. It can be read from the known positive value of z1 from the standard normal table. And how to evaluate the normal probabilities. One thing you have to keep in mind that directly the normal probabilities cannot be evaluated by integration. First of all, as it is continuous variable, that's why we are talking about integration. But every normal has to be converted to standard normal using the rule value of the variable minus its mean divided by standard deviation. Then we have to use the standard normal table to calculate the required probability. For example, suppose x is normal with mean mu and standard deviation sigma, and if you are willing to calculate the probability that the normal variate lies between A and B. Therefore, as I told you, first we have to convert that normal to standard normal, because directly we cannot evaluate normal probabilities. That's why, first of all, that normal variable has to be converted to standard normal. Then we have to use the table. In order to convert this normal to standard normal, subtract mean throughout and divided by standard deviation. And if I subtract mean throughout, that is mu, it gives you A minus mu is less than or equal to x minus mu is less than or equal to b minus mu. And if we divide by standard deviation throughout, it will be divided by sigma. Everywhere you are going to get equals to, it is party of, once the value of a, mu and sigma are known, this seems to be one constant. Let us call it as C1. And we know that x minus mu upon sigma is standard normal variate. It is denoted by z. And again, for known values of b, mu and sigma, this seems to be another constant. It is denoted by C2. Okay, where C1 is given by A minus mu by sigma, and C2 is given by B minus mu by sigma. With this particular thing, we have to keep in mind that every normal probability cannot be evaluated directly. First of all, that normal variate has to be converted to standard normal variate according to this rule, and we have to calculate the expression, or the moral of this is, in order to calculate, or the calculating the probability that a normal variate lies between A and B is as good as calculating the probability that the standard normal variate z lies between C1 and C2, where C1 is given by this and C2 is given by this. And this is all about the theoretical aspect of that normal distribution and standard normal distribution. First of all, one thing should be kept in mind, that normal probabilities cannot be evaluated directly. First of all, normal variable has to be converted to the standard normal variable by using the mean value of the variable, means by using the rule value of the variable minus its mean divided by standard deviation. And here we have said that the curve is symmetric about the line z equal to 0, and the shaded area in the figure represents the probability that the standard normal variate lies between 0 and z1, and it is read from the standard normal table for a known value of z1. Okay, at the end of this particular page, at the last, okay, mention this standard normal table by which we can use the values or the probabilities which are required to do for calculation of normal probabilities. Whenever we require, once again, let us refer this table and let us take the respective values from the table. Now let us go for getting going with some simple examples to get an idea how to calculate the normal probabilities. A simple example, and this one example will clear all variety of probability evaluation with respect to normal distribution. And the example goes like this. A normal variate has mean 42 and standard deviation 4. Then find the following. First one, probability of x is less than 50. Second one, x is greater than 50. Third one, x is less than 40. Fourth one, x is greater than 40. Fifth one, x lies between 43 and 46. Sixth one, x lies between 40 and 44. Seventh one, x lies between 37 and 41. Now let us go one by one. Okay, now they are given, or we can say that I'll consider one variable as a normal, which has a mean 42 and standard deviation 4. So we can call let x follows normal with mean 42 and standard deviation sigma. As we know that, first of all, normal has to be converted to standard normal, and it is given by value of the variable, that is x minus mean divided by standard deviation, that is z equals to x minus mean is 42 and standard deviation is 4. Now let us consider the first one, that is consider probability that x is less than 50. Now it is normal presently. Now in order to get its probability, first let us convert that one to standard normal using the rule subtract mean divided by standard deviation. If I subtract mean from this, that becomes minus 42 divided by standard deviation, that is divided by 4. In the same fashion here also, if I subtract mean and if I divide it by standard deviation, we are going to write like this. That's why in order to convert normal to standard normal, we have to subtract mean throughout and we have to divide by standard deviation. In this case, mean is 42, we have subtracted throughout, and standard deviation is 4 and divided by standard deviation. Now, property of this x minus 42 divided by 4, that is your z that I have written here, and this becomes less than 2, because 50 minus 42, that is 8 by 4, that will be 2. Okay, now here we have to calculate property of z is less than 2. Now let us draw the standard normal curve for this, and 2 is positive. Somewhere on right side of 0 you can mark that, and we want the area. Probability means when you are dealing with continuous variable, probability is referred as well as area, and we want the area where z is less than 2. Less than 2 means below 2. Therefore, you have to mark entire area below 2. Okay, now as we know that from the standard normal table, okay, we can read the area from 0 to something. Okay, because of that, every situation has to be converted to be in the form of 0 to something, so that we can read the area or probability from the standard normal table. And in this case, we want the probability that minus infinity to 2, or I want to calculate the area from minus infinity to 2. This can be written as, that is area from minus infinity to 0, that is left half, plus area from 0 to 2. That's why we have written area from minus infinity to 0, that is this area, plus area from 0 to 2. And area from 0 to, so minus infinity to 0, that is nothing but 0.5. As it is left half, we know that the total part is 1, left half course 0.5 and right half course 0.5. Because of that, it is 0.5. And now I want the area from 0 to 2. Okay, that's why let us refer that standard normal table. Okay, that is it is here. Therefore, you come for Z and Z value is 2. I think it is 2 is here. And for Z equal to 2, the area is 0.4772. Therefore, now let us go there, and area for that 2 is that is 0.4772 we have taken, and the sum of them is going to be 0.9772 we can call. Okay, this is the probability that a normal variate x is less than 50. Now consider the second one, that probability of x is greater than 50. Now again, this is normal. Convert that one to standard normal by subtracting mean and dividing by standard deviation. And by that, we can get z is greater than 2. Again, 2 is a positive value which lies right side of 0. And now I want the area greater than 2. Greater than 2 means above 2. You mark the area above 2. We want this particular area now. Again, directly we cannot get that area because from the table, we can get the area from 0 to something. That's why you convert this situation from 0 to something. I want this area. In order to get this, what I'll do, I'll consider right half, and from that I'll take out the area from 0 to 2, so that I'll get the remaining. That's why I'll say that this can be computed as area from 0 to infinity, that is right half, minus area from 0 to 2, that is the area from 0 to 2 already you read once, that is 0.4772, that is zero point 0.5 minus 0.4772, that is given by 0.20228. That is the probability that the normal variable x is greater than 50. And we have one more option, that point of x is greater than 50. If I use the complement rule, I can say like this: 1 minus point of x is less than or equal to 50. That is less than 50 already have computed in the first case. Its value is 0.9772. If you take out that one from 1, you will get the same answer. But here, why I am going like this, you must expose all varieties of probability evaluation with respect to normal distribution. Now let us go to the third case where we want the probability of x is less than 40. Again, you subtract mean throughout, that is 42 divided by standard deviation. That leaves probability of this x minus mu by sigma, that is the mu minus sigma, that is x minus 42 by 4. That is our standard normal variate that we are denoting by z. Z is less than 40 minus 42 is minus 2, minus 2 by 4 is minus 0.5. And minus 0.5, I want the area now where z is less than minus 0.5. Minus 0.5 is, it lies left of 0, that's why somewhere you have to mark that minus 0.5, and you want the area which is less than that. Less than that means below that. Therefore we want this shaded area. Again, in order to convert the area from 0 to something format to use the standard normal table, this area which is required, I can write it as left half. Left half means area from minus infinity to 0 minus area from 0 to minus 0.5. That is the area from 0 to minus 0.5. That is this area from minus infinity to 0. That is left half, it covers 0.5. Now, you should be very careful that here it is minus 0.25. From the standard normal table will not have any negative value. We cannot read for a negative value of z. Therefore, then the next question, how we can do that? As we know that the curve is symmetric, okay, because of the symmetry, even though the curve is, the value is minus 0.5, it can be taken as plus 0.5, because whenever a curve is symmetric, minus 0.5 is at the same distance of that of plus 0.5. Therefore, because of the symmetry, this minus 0.5 can be taken as plus 0.5. That's why we have taken that one as by symmetry. This is 0.5. Now we want the area from 0 to 0.5. Again, let us come for the normal table. Please note that this table will give the area from 0 to something. Now I want for 0.5. I think 0.5 is here. Therefore, corresponding value is 0.1915. Therefore, if you use that, okay, that is if you use the value here 0.1915, let us see what we get there. Therefore, this will be 0.1915. Therefore, its value is going to be 0.3085. That will be the third one. Now let us concentrate on the fourth one. That is, consider property of x is greater than 40 and that one equals to, that is x, again if you subtract mean and divided by standard deviation, it gives z is greater than minus 0.5. Minus 0.5 is here and I want the area greater than, means above that. You can shade that. Therefore this area can be written as area from 0 to infinity plus area from 0 to minus 0.5. And since, as we know, minus 0.5 is at the same distance of that of plus point, from the table we can read the value for 0 to 0.5, and we know its value is 0 to zero point 0.5, that is 0.1915. Therefore 0.5 plus 0.1915, that leads to 6915. Now let us go for the fifth one, that x lies between 43 and 46. Again, if you subtract mean throughout and if you divide by standard deviation, therefore this becomes 43 minus 42, 1 by 4, that is 0.5, and this is our result, and this is nothing but our 46 minus 42, 4, 4 by 4 is 1. Therefore, now I want the value or the area or the property between the area between 0.25 and 1. And since both are positive, 0.25 is nearer to 0 as compared to 1. That's why I'm marking 0.5 first, then I'm marking 1. Therefore, I want the area between those two. And in order to get this area, keeping in mind that from the standard normal table, we can read the area only from 0 to something. This can be obtained by taking area from 0 to 1 minus area from 0 to 0.25. Now, what is the area from 0 to 1? Again, you come for standard normal table, and for 1, its value is 0.3543, sorry, 3643. Okay, 3643, let us say that is point where is that? This one lies between, okay. I think this one, 0.3413, area from 0 to 1 minus 0.0987, that is area from 0 to 0.5. And once again, let us check for 1, what is that? For 1, it is 0.3413. Okay, and for 0.25, 0.2 and mean a difference 5, that is 0.0987, that is 0.0987. Now for this one, that is 0.3413 minus 0.0987, its value is going to be 0.3426, sorry, 0.2426. Now for the next one, it is, we want the probability that normal variate lies between 40 and 44. First, let us subtract mean divided by standard deviation. We'll get it as minus 0.5. This one is z and this one is plus 0.5. Minus 0.5 lies left of 0 and plus 0.5 lies right side of 0. And we want the area between those two. That's why you are shaded. That's why you are written. It is area from 0 to minus 0.5 plus area from 0 to 0.5. You have to add these two. And we know that both the parties are same. If this area is equals to this, that's why I can write area from 0 to 0.5. Its value is 0.1915. Okay, we can show that for 0.5. Let us see, for 0.5, its value is 0.1915. That is why we have taken its value as 0.1915, and because of the symmetry for this one also I can take the same thing as 0.1915. That gives you 0.383. And now let us go for the last one, that we have to consider property that normal variable lies between 37 and 41. If you subtract mean throughout and if you divide by standard deviation, you will get it as minus 1.25 is less than, that is less than minus 0.25. When you go far away, the value of on left side, the values will go on decrease. That's why first I will take minus 0.25, then I will take minus 1.25, and we want the area between these two, and this can be written as area from 0 to minus 1.25 minus area from 0 to minus 0.25 I can write. And once you go for this, and because using the symmetry, okay, we can write like this. Okay, that's why the area from 0 to 1.25, that we will check here for the table. Area from 0 to 1.25, 1.2 is here, and the mean difference, that will be 0.3944. Okay, that will be 0.3944, we can say, that is 0.3944. And area from 0 to 0.25. Okay, in the previous problem here we got the area from 0 to 0.25, that is 0.0987, that is 0.0987. Its difference is going to be like this. Okay, that will be the required value, we can say. And see here, with this one example, we are exposed, okay, to find all probabilities of all the kind as far as normal variant is concerned. Now, knowing this basic example, now let us use the knowledge to solve different kind of examples on norm. Now, come for this one, another second example, and it goes like this. In a test on 2000 electric bulbs, it was found that the lifetime of a particular make or a product was normally distributed with average life of 2040 hours and a standard deviation of 60 hours. Estimate the number of bulbs likely to burn. First one more than 2150 hours, second one 15, 19, 20, and 2160 hours. Once we read out the problem, it indicates that the information is regarding lifetime of the electric bulbs. That's why let us take the variable x as lifetime of the electric bulbs in hours. And it is a straightaway information that lifetime follows normal with the mean, what is that, 2040 hours and standard deviation of 60 hours. That is also given. So let us take that one. Now, once you know normal, we can write on standard normal by subtracting mean dividing by standard deviation from the normal variate. That is given by x minus mu by sigma. That is x minus mu is 2040 divided by 60, where capital N is number of bulbs put on test. And they have said in a test of 2000 electric bulbs, therefore capital N seems to be 2000. Now here in the problem, nowhere we observe the word find the probability. But here they asked number of bulbs, means they asked the frequency. But in order to find the frequency, finding the corresponding probability is must, because theoretical frequencies are obtained by f of x equals to n into p of x. That's why first let us find the probability for the required situation. Then by multiplying that one by capital N, we get the required frequency. In the first case, we want the number of bulbs likely to burn more than 2150 hours. Means first let us find probability that a bulb will burn more than 2150 hours. That's why, and that finally is given by, when you multiply that one by n, it will be the number of such bulbs. That is, if you want to find number of bulbs likely to burn more than 2150 hours, it is given by, according to this rule, n into probability of that situation. That is, lifetime of the bulb is 2150 hours. That is 2000 into lifetime is taken as x is greater than 2150. Since this is normal, convert that one to standard normal by subtracting mean on both sides, dividing by standard deviation. That is, mean is 2040, standard deviation is 60. If we go this one, this will become z, and this is greater than, and this value is going to be, when you calculate, its value is 1.83 will get. Now, here first let us find the probability that the z will greater than 1.83. And 1.83 is positive, that lies the right side of 0, that's why I marked somewhere here. And I want the area greater than that, greater than means above that. That's why this area is shaded. This 2000 as it is, Now, in order to get this area, we can say that one as right half, that is area from 0 to infinity, minus area from 0 to 1.82, that we can write. This is 2000. Area from 0 to infinity means right half, because total part is 1, right half covers 0.5 and left half covers 0.5. That is why we can take that right half as 0.5. Okay, then area from 0 to 1.83. That's right. Now let us refer the table. Come for 1.8 and mean difference 3. Okay, that will give you 0.4664. That will give you 0.4664. Now let us take use of that. That is 0.4664. And once you take the difference, that gives you 0.0336. Once you multiply this one by 2000, you will get a 67.2, and that is approximately equals to 67. Okay, now let us go to one more example. Okay, sorry, the second requirement. That is, in the second case, we want number of bulbs likely to burn between 1920 and 2160 hours. Again, here we want the frequency according to this rule, that is capital N into probability of that situation, that lifetime of the bulbs lies between 1920 and 2160. That means lifetime, that is x lies between 1920 and 2160. Again, convert this normal to standard normal by subtracting mean and we are dividing by standard deviation. And once you take this one simplification, this becomes -2, and this is z, and this becomes +2. And this 2000 as it is, as we know that once you plot this one, okay, -2 is left side, +2 is left side. I want the area between these two, and we know that area from 0 to -2 is as good as area from 0 to 2. That's why this total area can be written as 2 times area from 0 to 2. This is 2000, this is 2. Now what is area from 0 to 2? From the standard normal table, that is, once you come for 2, its value is 0.4772. Let us take use of that value as 0.4772 into 2. We'll get this when you multiply by that one by 2000. Okay, its value is going to be 1908.8. That will be 1909 million. That's a way how we can calculate the number of bulbs likely to burn between 1920 and 2160 hours. That will be the second example. Now let us go for one more. That is, in an examination taken by 500 candidates, the average and standard deviation of marks obtained are 40 and 10 respectively. Assuming that the marks are normally or marks obtained are normally distributed, how many will pass if 50% is fixed as minimum? Second question, how many have scored above 60? And third one, what shall be the minimum marks if only 350 candidates are to pass? Once we see the given information, we find that the information is regarding marks scored by the students. That's why let us take the variable x as marks scored by the students in an exam. And they are given another information that the marks are normally distributed with mean 40 and standard deviation 10. That's why we can write x follows normal with mean mu equal to 40 and standard deviation sigma equals to 10. And once we know normal, we can write on standard normal as z equal to value of the variable minus its mean divided by standard deviation. That's why it will be x minus 40 divided by 10 we can write. And we can write one more capital N that indicates the number of students taken the examination. Okay, now first we want probability, first we want how many are scored above, how many will pass if 50% is fixed as minimum. As we know from the previous example, again in this case also we want frequency. Therefore, in order to get the frequency, first of all finding the corresponding probability is must. That's why First, let us consider probability of passing. Now, in this case, when the student passes, in the first case, the student passes if he scores 50 or more marks. That's why here we have taken X as marks, that scoring should be 50 or more. That's why passing will be taken, considered that only when he or she will score 50 or more. That is X is greater than equal to 50. Again, this is normal. Convert that one to standard normal by subtracting mean 40 and dividing by standard deviation 10. We'll get this one as Z that you have denoted here. And once you take 50 minus 40, 10. 10 by 10, that will be 1. Now, probability of Z becomes greater than or equal to 1. Now, we have to find the probability that Z is greater than or equal to 1. Now, once you draw the standard normal curve, it is going to be like this. And this 1 is somewhere lies at the right side. Okay, greater than 1 means above 1. You have to mark it. Again, this property can be obtained as area from 0 to infinity, that is the right half, minus area from 0 to 1. Once we refer the table area from 0 to 1, that is 0.3413. That is 0.3413. That is 0.3413. 0.5 minus 3413 is 0.1587. This is the probability that the student passes if 50% is fixed as minimum. But that is not our interest. Our interest is to know how many students are of such caliber. That's why number of students passing the exam if 50% is fixed as minimum is given by capital N into probability of that situation. Because of this fact, capital N means 500 students have taken the exam and probability of passing, that is probability of X is greater than equal to 50 is 0.1587 that we have computed. Once you calculate this, it results as 79.35, that is almost 79. Means out of 500 students those who have taken the exam, we may expect 79 students being capable of passing, even though if the minimum passing percentage is fixed as minimum. That will be the required answer. Now, in the second case, we want how many students are scoring greater than 60. That's why first consider probability of the student score, the value means marks greater than 60. Again, once you subtract mean divided by standard deviation, that gives you probability of Z is greater than 2. And this can be computed as area from 0 to infinity, okay, minus area from 0 to 2. And once you read the area from 0 to 2 from the standard normal table, okay, for 2, its value is 0.4772. That is 0.4772. 0.5 minus this is 0.0228. Therefore, the number of students scoring above 60 is capital N into corresponding probability. That is 500 is capital N, that is 0.0228. Once you take the product, it is approximately equals to 11. That means out of 500 students, we may expect 11 students to score above 60 marks. Now let us go for the last case. The last case is somewhat different, and the last case they asked what shall be the minimum marks, okay, if only 350 candidates are to pass. First, we don't know what is the minimum marks to be proposed for passing. That's why let us say A be the minimum marks for passing when only 350 candidates are to pass. Now, probability of passing. Okay, probability of passing is given by out of 500 students, only 350 students are going to get the promotion. That's why probability of passing is given by 350 divided by 500. That will be 0.7. And when the student passes, and since you have taken A be the minimum marks for passing, that's why passing criteria can be written as probability of X marks scored is greater than or equal to A. Means if the student scores the marks A or more, then only he or she is going to pass. That's why probability of passing criteria is written as probability of X is greater than or equal to A is 0.7. Again, it is normal. Convert that one to standard normal. Subtract mean divided by standard deviation. That is X minus 40 by 10, A minus 40 by 10 equal to 0.7. Now that is this one is z. Since a is unknown, therefore this quantity cannot be calculated. So let us note it as z equals to 0.7. Now where z1 is a minus 40 divided by 10. Now we have to find the probability that we have to find the value of z1. For what value of z1? The probability is 0.7. Once you trace this one, okay. Now the question is why we have taken z1 at the left. That's the question. First, we don't know where that has to be chosen. First, let us take z1 at the right side somewhere. Z1. Now area above that Z1 is definitely going to be less than zero point 0.5, because even though if we take Z1 at the middle, at the center, then the area above that one will be what? At the most 0.5 we'll get. But here the area seems to be 0.7. That's why it has to be at the left of 0, because this is 0.5, we want something more. In order to get that something more, our Z1 should lie at the left of 0. Somewhere here we have taken that Z1. Now we can say that area which is marked, that is area greater than Z1 is 0.7. And we know that right of is 0.5. Then the remaining area, that is between 0 and Z1 is 0.2. That's why from this diagram we can say that the area or the probability between 0 and Z1 is 0.2. Now it is somewhat different situation. So far, for a known value of z, we have computed the probability. Now for this problem, we know the probability. Now we have to calculate for what value of z1 the probability is 0.2. It is a reverse process that can be obtained using the standard normal table. Now let us explain about that one. See here, so far by knowing these z values, we have calculated the probability. But in this case, we know the probability and we have to find what is the corresponding value of z for which the area or the probability is 0.2. Means now inside the table, you have to search the value 0.2 or the nearest value for 0.2. Okay, once you go on search the nearest value for 0.2, okay, that seems to be here. Okay, see here it is 1985, and here it is 0.2019, and here if you take this one, here we are leading by 19 units, and here we are lagging by 15 units. That means this one is nearer to 0.2 as compared to this. That's why let us take this value, because we cannot get exactly 0.2. That's why let us take the nearest value, which is the nearest value is 0.1985. The corresponding value of z is 0.5. Mean difference is 2. That is 0.52. Okay. Let us take that value as 0.52. I think that one has 0.52. Z1 value is 0.52. For Z1 equal to 0.52, we get the area as 0.7. Now see why we have taken negative sign for that. As it is evident that Z1 lies left of 0, okay, that's why you have to take Z1 as negative. Therefore, Z1 becomes minus 0.52, and Z1 value we know that will be 40 minus, sorry, A minus 40 by 10. That one equals to A minus 40 by 10 equal to minus 0.52. By cross multiplying, it becomes A minus 40 equal to minus 5.2. Therefore, if you take this 40 on the another side, A becomes 40 minus 5.2. Once you simplify, it becomes 34.8. That is approximately 35. That means if our intention is to promote only 350 candidates to go for the next class, we have to propose minimum marks for passing as 35. That will be the required solution for the third case. And these are some of the examples. Still many examples are there in the next video also. Now let us deal with some more examples on normal distribution. Thank you.